Hi friends, welcome to InfoStreet channel. So today's our topic is shading and deshielding effect. This shading and deshielding effect will come in an NMR spectroscopy. So let's see its definition. When the magnetic field applied on the nucleus, then it produces a magnetic field is called a applied magnetic field. B0. The electron revolve around the nucleus, it produces a magnetic field. This magnetic field is called a secondary or a induced magnetic field. When an applied magnetic field and secondary or induced magnetic field in the same direction, then this effect is called a deshielding effect. When the applied magnetic field and secondary induced magnetic field are a opposite direction, then this effect is called a shielding effect. So it's a definition, and let's see how it works. So you can see this magnetic bar. Here it is a north pole and this is a south pole. Here we can see this green arrow. These are the applied magnetic field, and we can see this blue dotted lines. These are the electrons which is revolving around this nucleus. Okay, we should clear this. Afterwards we can see this. These are the electrons which are revolving around this nucleus. So when it is revolving around the nucleus, it may produce or it will produce some magnetic field. So this magnetic field is called this is the first statement. That's why you can say it is a secondary magnetic field, or we can also see it is a induced magnetic field, because it is producing itself with the electrons, or when the electron is revolving around the nucleus. So that's why it produces a induced magnetic field. So these blue arrows we are seeing these are the induced magnetic field or a secondary magnetic field. So now what will happen means, when this induced magnetic field and this applied magnetic field are in a opposite direction. So see here, it is in this way and this is in this way. So when it is opposite in this direction, so this will produce a deshielding effect, or we can also see this is a upfield. This upfield will come in a TMS or this chemical shift way. In that time we can discuss about this. Okay, now point outing this only shielding effect. So opposite direction of a magnetic field, induced magnetic field and applied magnetic field are called as a shielding effect. Here we can see this applied magnetic field and this induced magnetic field are in the same direction. So when it is in the same direction, it is called a deshielding effect. So this is a downfield. As we say is that it will come in a chemical shape. Let's discuss in that time. So now deshielding effect. So here we can see this is a nucleus, which is, we can see this here. This is a nucleus and it's revolving around the electrons. These electrons will produce a magnetic field, that and it is a induced magnetic field. Okay students, I hope we are thorough this shielding and deshielding effect. So you can take a screenshot of this and we can learn this.